So this is lesson 5.8, day 1. So here you're going to be learning about how to find X-intercepts as well as local minimums and maximums using a graphing calculator. Now you learned already how to find your zeros, another word for solutions, or the X-intercepts, using the rational zero theorem as well as synthetic division. Now we're going to use graphing calculators to find all that information. Now before we do that, we need to go over some vocabulary. The first one is what we call turning points. Turning points is just another word or another way of saying local minimums and maximums. When you guys were doing quadratic functions last unit, you guys learned about minimums and maximums. Remember, local minimums, that is where we would have our lowest point on the graph, while maximums is where we will have our highest point on the graph. So we're also going to be calling these turning points. Now, local maximum, this is the y-coordinate of a turning point, and it's higher than all the nearby points. That's why it would be a maximum. While local minimum, that is the y-coordinate of a turning point when it's lower than all the nearby points. Let's look at a graph to know what a minimum and maximum is. So we have this graph here, okay, in this case it's just a cubic function. We have a local maximum at this green point. We know it's a local max because it's higher than all the nearby points. While we look here, we have a local min. So this point's a local min because it is the lowest point or lower than all the nearby points. Now before we use a graphing calculator, let's go ahead and given a graph, we're going to find our local max, our local min, and our real zeros. Remember, real zeros is another way of saying X-intercepts. So here, we're going to estimate the coordinates, so they don't have to be exact, of the turning points. Remember, turning points are local minimums and maximums of the graph, and state if it's a local min or max. Then we're going to estimate all the real zeros and determine the least degree of the function. So let's talk about our local max. Now if we look at this function right here, you might have to draw in your notes. If not, that's good. If we look here, we have where we're going from, our graph is going from up and then going back down. Here, that's going to be our max. So we're going to just estimate what this point is. So that is writing it as a coordinate point. So our x value is at -1, and since we don't move up or down, then our y value is 0. So our point for our local max is -1, 0. Now we're going to find our local min. Now here, remember, our local min is the lower point of all nearby points. So we can see it's at the bottom here. Now let's go ahead and estimate this point. So we go over here 1, so that's our x value. And then our y is 1, 2, 3, 4. So we're here at -4. So our local min is at 1, -4. Now our next thing is we have to find the real zeros. Now remember, zeros is another way of saying x-intercepts. X-intercepts are points that cross the x-axis. Right here, our horizontal line is our x-axis. So we look on the green points that are on the x-axis, those are our zeros. So our first one, right over here, if we're estimating, is -1, 0, which is also our local max. Now we look for another green point that's on the x-axis. We go over 1, 2, okay, and once again our y value should be 0 here. So our other point is 2, 0. Now the next thing we need to figure out is our least degree. Now this is just saying what could be our exponent on this function. And what could be the least amount that we get? Well, if you look here at this point at our x-intercept of -1, 0, it looks like that our function is touching it. Remember, touching is you hit the x-intercept and you come back, just like if you're bouncing a ball. So we know when we are touching an x-intercept, we have to have a multiplicity where it's even. So whenever we touch the x-intercept, the multiplicity needs to be even. Okay. Now we look at our other one, it looks like our graph is going straight through our point. So whenever we're crossing at an x-intercept, that means we have an odd multiplicity. Now what we need to figure out, right, well, the lowest even multiplicity we can think of, or the smallest even number, is 2. So this could be a multiplicity of 2, while our lowest multiplicity for odd could be 1. So that means if we added our 2 and our 1 for a multiplicity, we would get a degree of 3. So I'm going to go ahead and write that information down so you guys have that. So the lowest even number we could have is the number 2. And the lowest odd value we can have is 1. So the smallest degree we can have total is 3. Okay. So that is how we would find our local max, our local min. Remember, these are what we call turning points, as well as our real zeros, just using a graph. Now, what we're going to do next is find all this information, but now using a graphing calculator. So go ahead, make sure you have your graphing calculator with you. I would suggest when you're doing these problems here that you go along on your graphing calculator so you know how to do this. So the first problem we're going to do is f of x equals 0.5, or you can do a half x cubed, minus 2x plus 2.5. So I'm going to go to my graphing calculator and plug that into my function. So what I need to do first is I need to go to y equals. In my y equals, I'm going to plug in that function. So we had 0.5. Now we press the x button, which is right next to alpha. And then I use my caret key. So that'll give me my exponent. So I do a caret key. And because I want a cube, I put 3. Now to do the rest of the problem, I do have to write arrow over. Now I put in minus, make sure you use the minus button, 2, and then the x, and then we'll have plus 2.5. Now remember, if you ever need to, make sure you pause the video if you need to stop and redo something, or make sure you go back if you need to. So here I have my function. Now what I'm going to do is go to what is called the window key. This allows me to show the graph. So I'm going to press window. And what I'm going to do is make what this says is x min. That is my lowest minimum, or x value. I'm going to leave it as -10. My x max, I want it as 10. And I'm going to leave my x scale as 1. Now going to my y min, I'm going to leave it as -10. But if you look, I'm going to change my y max. I just downed arrow there so I can get all the way to my y max. And to get rid of that, I'm just going to press clear. And then I'm going to do not -10, but +10 for my y max. Once I have that, I'm going to change my scale into ones. So this is what we would call our standard window, okay, because this is what usually you'll use to figure out what a graph looks like. So now I'm going to go to the blue button second. Sorry, don't press second. I'm actually just going to press graph so I can graph this function. If you wanted to see the table, as you can see here, that's when you would use second graph. So all I'm going to do is just press graph and see what my function looks like. Okay, so here I'm just going to draw a sketch on this on my notes so we can talk about how to find our x-intercepts, the local min, and the local max. And when we find all of these, we're going to write them as ordered pairs. Okay, now I'm going to draw a sketch of the graph that we just had on the graphing calculator. Now, it does not need to be perfect. Just because of this purpose, I'm just going to show you why we're doing some of this stuff here. Okay. Now, the first thing we're going to do is find the x-intercept. Now, if you look at our function, and I'm going to show a little bit better on a graph here, we only touch the x-axis once. So the graph goes through that, meaning since our graph only touches or goes through the x-axis once, we're only going to have one x-intercept to find. Okay, I'm going to make that color here green. Okay, so that's what we're trying to find, the green dot here. Now, to find the x-intercept, here we're going to press the second key, so the blue one, and trace. Trace is the button right next to zoom in graph. Now, because I'm trying to find an x-intercept, remember another way of saying x-intercept is what we call 0. So I'm going to go to my number 2, and I just down arrow for that, and I'm going to press enter. Now it's going to ask you for a left bound. To figure out what left bound means, I'm going to draw on my sketch just like an imaginary line here. Okay? Now imagine this line here, and we need to figure out what is the left-hand side of this line. Well, basically it's anything it looks like below the x-axis. So what I'm going to do is when I go back to my graphing calculator, I'm going to put my cursor anywhere on the graph that is below the x-axis. So that's why I put an X here. That is going to represent our left bound. Okay, so this X here is our left bound. Now going back, that means moving my cursor, I can only use the right and left arrow keys here. Those are the only keys I can use. So I need to get below this x-axis over here. So that means I'm going to use my left arrow key and go right underneath the x-axis. Now it does not matter where your cursor is, it just needs to be somewhere below the x-axis. And then from here, I press enter. Now it asks me for the right bound. Well, let's go back to our imaginary line here. So now I want to pick a spot that's to the right of this line. Well, that looks like anything that is above the x-axis. So what I'm going to do is put my cursor somewhere above the x-axis to represent my right bound. Okay, going back here. So that means because I want to go above the x-axis, I have to use my right arrow key, and it just needs to be somewhere above it. Now, once I've got to right bound, I press enter. Now, whenever it asks you to guess, we're going to press enter one more time. And then here it gives us our 0, where the graph crosses the x-axis. I'm going to round to 2 decimal places. So my x-intercept, or my 0, is negative 2.46. So I'm going to go ahead and write that. So on your notes, you're going to write for your x-intercept negative 2.46. And remember, we're writing this as an ordered pair, so our y value should be 0. Okay, make sure if you need to, pause when you need to stop and do some things on your own, okay? Okay, our next thing is we're going to find the local minimum of our function. Now I'm going to erase this, okay, so then at least we can see what a local min looks like. So I'm going to redraw a sketch of our graph. Okay. Now we're trying to figure out our local min. Remember, that is the smallest point of all the nearby points. And that's really looking like whenever your graph is coming down. So this dot that I just made right here, this is our local min. Okay. Now using our graphing calculator, I'm going to go once again back to second, so press second, and then the trace button. Because we're finding a minimum, I'm going to go to the word that says minimum. This will allow me to find my local min. So press enter. Now once again, it asks us for a left bound. Basically what it means for left bound is we need to be on the left-hand side of our hump. So here's our local min, so we got to be on the left-hand side. Kind of going back to our sketch, we got to be on the left-hand side of our point. So right here, this would be our left bound. So I'm going to move the cursor over. And it just needs to be somewhere on the left-hand side of your hump here. So I press enter. Now it asks me for my right bound. Well, that means I got to be on the right-hand side of this hump. So I move my cursor to the right using the right arrow key. And make sure that you're over the hump when you're doing the right bound. So I'm going to put an X here to represent this is my right bound. Okay. I press enter. And then remember, whenever you have guess, you got to press enter one more time. And then here's my minimum. For both of these, I'm going to round to 2 decimal places. So my X value is 1.15. So I have 1.15. And my Y value, as you can see, was 0.96. So remember, make sure you write your answer as an ordered pair. Okay, last thing is we're going to find the local max. So once again, I'm going to erase this so I can show you how to find the local max. I'm going to draw a sketch of our graph. Okay. Remember, local max is basically the highest point of all the nearby points. So that's going to be like at the top of a hump here. So here's our local max. Okay. So we're going to do something similar just like we did with local min. So we're going to go once again to our second, so press that, to trace. Because we're finding our maximum, we're going to go to number 4. And you're going to press enter. So here's our local max, is at the top of our hump. So we got to make sure we're on the left-hand side of this hump. So we go back to our sketch. That's going to be anything over here. That's going to be your left bound. Okay, so I'm going to use my left arrow key. Make sure you go over the hump, and then your cursor just needs to be somewhere, anywhere on that left-hand side. Once you got it there, I'm going to press enter, and then it's going to ask me for the right bound. So right bound's on the other side of the hump. So you're going to put your cursor there, and then press enter. So that means I need to use the right arrow key. Make sure you get over the hump, and then somewhere around in between here. And then we're going to press enter. Remember, once ever it asks you for guess, you press enter one more time. And then you get your X and Y value for your local max. So our X value is negative 1.15. And then our y value is 4.04. So make sure you round up for that. There we go. And make sure you write your answer as ordered pairs. So that's how you find your x-intercept, local min, and local max using a graphing calculator. Now we did this when we had a cubic function. Now we're going to do the same thing, but when we have, in this case, a x to the fourth. Okay. Now here, this is just some of the instructions if you want to pause and write this down or take a picture of how to find the x-intercepts. I basically just did that using the graphing calculator. So if you need to pause the video and look at it or take a picture of it, you can. And then here are the instructions to find the local max and minimum of the problem that we just did. So once again, if you need to take a picture of this or write it down and pause the video, you can do that as well. Okay, let's go ahead and do our next one. So now we have it to the fourth power. So we're going to do the exact same thing as we just did with our x cubed. So here we need to go back to our y equals and press clear. Now I'm going to go a little bit faster on this because a lot of the steps that we did for the last problem will be the exact same here. Now make sure if I'm going too fast, you either pause it so you can take time to write the information down, or if you need to go back, make sure you do that. So I put x to the fourth, so we have the x button, then the caret, and I'm going to the fourth power. I need a right key over, then I do minus 5x. Once again, I need to do the caret key, cubed. And then I have plus 2x squared, so plus 2x, and then squared. And then plus x, and then minus 3. Make sure you use that minus. Now, just like we did before, I'm going to go to graph. Okay, so press the graph button. Now, as you can see here, sometimes when you graph things, they're going to be cut off. Whenever this happens, that means that we need to change our window so we include the entire graph. To do this, I'm going to go back to my window, so press the window button. And here what I'm going to do is I'm going to change my y minimum because it looks like that I have some more graphs kind of more in the negative direction here. So I'm going to go to where it says y min, so I do got to change that. Here is just kind of like a guess and check to see what works. I'm going to go to negative 20 to see if that works. And while doing that, I'm just going to change my scale from a 1 to a 5. Now we're going to see if this is low enough. And if it's not, we might have to change it again. So I'm going to go back to graph and see if my entire graph is still on here. Well, if you look here, it's still not part of the graph. So I have to continue to change my window. So I'm going to go back to the window, and let's change it to negative 30 and see if that will work. Okay, let's press graph again. Well, it looks like we're almost there, but still we don't have the entire graph here. So the last thing I'm going to do is I'm going to go to, let's say, negative 50. And then that means I'm going to change this, my y scale, into tens to kind of help me out. So now I'm going to graph it. And it looks like I got all of my graph here. So that's good. Okay, so the first thing we need to find are x-intercepts. So we look at our graph here. It looks like that it touches or crosses the x-intercept at two separate places. That means when we're trying to find our x-intercepts, we will have to do the process twice. Now I'm going to go ahead and just draw a sketch of our graph. And then here, the blue dots, those are x-intercepts. So here on the first one, okay, we have to go, remember to get x-intercepts, we go to second trace, and we go to 0, so number 2, press enter. Now I'm doing the left-hand side. Remember, we have to do left bound. So here I'm trying to figure out what is the left-hand side of this line. Now I just draw this imaginary line to help me out to find the x-intercept. Well, it looks like here, anything above the x-axis, that's going to be my left bound. So I'm going to move my cursor then to get my left bound to find my x-intercept. So remember, you can only use right and left arrow keys. Now you might not be able to see my cursor, but it is above the x-axis, so that's good. So I'm going to press enter. Now ask me for the right bound. Well, it looks like here that my cursor has to be below the x-axis for the right bound. Okay, so that means I'm going to use my right to kind of get a little bit under, and it looks like I'm a little bit underneath here. Okay, I'm going to press enter. Now press enter one more time. And your 0 here is at negative. Once again, I'm going to round to 2 decimal places. Negative 0.77 and then 0. So we have negative 0.770. So that is our first x-intercept. Now remember, we have 2 of them. So we have to find the other one. Now, just like I did there, I'm going to draw an imaginary line to know my left and right bounds. So to find my other x-intercept, I'm going to go to second trace again, go to 0, press enter. Now left bound. If we look here, we got to figure out what's the left-hand side of this line. Well, the left-hand side looks like anything below the x-axis. So that's my left bound. So I got to move my cursor over to the right. And then I just need anything below the x-axis. There we go. So my cursor's below the x-axis, I press enter. Now my right bound, that's going to be anything that is above the x-axis, it looks like. Because that's on the right-hand side here of our line. So I'm going to move my cursor above the x-axis. Now you can't see it, but it is above. So that's all I need to make sure it is. Now guess, make sure you press enter last time. And then here we have 4.54. Now some of you might get this where you get E and then to the negative, maybe a number. This is just illustrating that we're getting very close to 0. So if you ever see this, maybe for a Y value or an X, when you're writing your ordered pair, just know that this really means it's 0. So our other point is at 4.540. Okay. So now what we need to do is we need to find our local max. So I'm going to erase this and then redraw it to find our local max. Make sure if I'm going too fast, you pause the video or rewind it. There you go. Now remember, local max is any point that's higher than any nearby. So this is like if you're going up a hill, it's at the very top. So we want to be at the top of a hump. Well, here I see a hump here. So that should be our local max then. Okay. So here I'm going to go to my graphing calculator. I'm going to press second trace. And you notice we really only have one local max. Sometimes you might have multiple. Okay. So since we're finding max, I go to number 4 maximum, press enter. Now we need to do left bound. So we have to do the left hand side of this hump. So I need to use my left hand cursor. And I have to be just somewhere on the left hand side of my hump. Okay. So 0, negative 3, that looks like it's a little bit to the left-hand side, so that works. Press enter. And the right-hand side, that's going to be on the right-hand side of our hump. And once you get somewhere on the right-hand side, you press enter. Remember, enter one more time for our guess. And then here will be our local maximum. Remember, round to 2 decimal places. So it's at 0.47 and negative 2.56. We need to write our answer as an ordered pair. So we have 0.47 and then negative 2.56. So our last thing we're going to do is find our local mins. Now if you look here, we actually have 2 local minimums. So we have to find both of them. So that means you're going to use this process twice to find your local mins. And remember, local minimums, they're basically at the bottom of a hump because they are the lowest point of all the nearby points. Okay, so going back to my graphing calculator, I press second trace. Now we're doing minimum, so I go to number 3, press enter. On the first one, I have to make sure I'm on the left-hand side of our hump. So that'll be over here. Press enter. Then I gotta be somewhere on the right-hand side of the hump. So this should be probably pretty good here. So I press enter. Press enter one more time. And then we get one of our minimums here. So the x is negative 0.16, and then our y value is negative 3.09. So we're going to write that down. So negative 0.16 and negative 3.09. Now we got to find our second local minimum. So I do the same concept. I go to second trace. And once again, I go to number 3 for a minimum and enter. I have to be on the left-hand side of this hump. So if I just need to put my cursor somewhere on the left-hand side. So I press enter. Then I move my cursor because I need the right bound. That means I need to be somewhere over on the right-hand side of this hump. Now make sure you go over the hump, okay? So that you don't include it. So now I press enter one more time whenever you have a guess. And then our final answer here is we have 3.44 and our y value is negative 3.4. So that is our other local minimum. So that is how you use a graphing calculator to find x-intercepts, local max and mins using graphing calculators. If you have questions, make sure you pause the videos and kind of go back. Make sure you work on these using your graphing calculator and go through with them. And if you have additional questions, make sure you ask in class or any time before or after school. The homework will be on Google Classroom, and you will only actually have 2 problems to work on. And I think I have it. There we go. So it will be page 390, numbers 22 and 26. And with these, you will only have to find the x-intercepts, the local minimums, and the local maximums. You do not need to graph the functions.